Hello everyone. This video covers section 4.1. We're gonna start probability. Probability is slightly different than a statistic and a little bit more tricky, but it's not that bad. In probability, you have the following elements. You always want to have a probability experiment. A probability experiment is a chance process that leads to well-defined results called outcomes. An example of this, it will be if you roll a die, if you flip a coin, or if you buy a lottery ticket. The tricky part, usually in probability, is to figure out the sample space. The sample space is going to be the set of all possible outcomes or everything that could happen. And usually this is the part that is tricky to figure out. At the beginning, this is very simple because you roll a die, clearly you can see that the outcomes are 1, 2, 3, 4, 5, and 6. If you flip a coin, well, there's only 2 outcomes, tails or heads, so that's easy. But what about if you buy a lottery ticket? How many outcomes you have? And this is where things can get a little tricky because it's not that obvious how many choices you have. And we'll get to that later. Now, an outcome is just a result of a single trial. For example, if you roll a die, it will be like getting a 4, or if you get a 5, or so forth. So there is 6 possible outcomes. For this one, there is only 2 outcomes. You either get tails or you get heads. That's it. This one is the one we'll get to later, which, how do you know how many outcomes you have? Now, most of the time, we're gonna focus on finding probabilities of events, not outcomes. They are completely related. So an event is just a combination of outcomes. For example, what's the probability of getting an even number or getting an odd number, and so forth. Now for this one, you only have 2 outcomes, and in this case, that means you only have also 2 events. This is the most simplistic experiment, which only has 2 outcomes. Now let's talk about probability types. There is actually 3 different kinds of probability, and we'll talk about all of that in the class. The first one is called empirical probability. This one is based on experiments. If you have no idea of what the probability of something is, this is probably the best way to find an estimate. The main issue with this method is that it can be very time consuming, so therefore it may not be very practical, but sometimes you'll see you have no choice, you have to do that. For example, let's say that you have no idea what is the proportion or probability that people in LA likes chocolate. Okay, so what you have to do is ahead of time you determine how many people you're going to ask. Let's say you ask 1,000 people randomly. The question will be very basic, whether they like chocolate or not. Let's say of those 1,000 people, 600 say yes, that they like chocolate. So therefore, an approximation to this probability, it will be 0.6 or 60%. As you can see, this is very simple, but it would require time because you need to physically ask 1,000 people. You can also do this online, but you have to ask people, and that takes time. The second kind of probability is called subjective probability. This one can be very biased because it's based on people's past experiences rather than computation. So this is pretty much like gut instinct. Hence, this is not very reliable, and it will be different for every person. The kind of probability we're gonna focus most of the semester is classical probability. Classical probability assumes that you have equally likely outcomes. That means that if you flip a coin, it should be the same probability getting heads as getting tails. Or if you roll a die, it should be the same probability to get a 1 than it is to get a 6, so forth. Classical probability is very easy to compute as long as you have the sample space, which I told you it can be tricky. Once you have found the sample space, then all you have to do is divide two numbers. So here NE means the number of outcomes in event E, and NS is the number in the sample space, which will be all the possible choices. For example, let's say that you want this event, getting an even number if you roll a die. Well, how many even numbers you have? 3, the number 2, the number 4, and the number 6. So the number of outcomes in event E, it will be 3. What is the number of outcomes in the sample space? 6. And that's it. It is that easy. You don't even have to simplify, but 3 over 6 will be enough. Let's do an example now where the sample space is not that easy to figure out. For example, let's say that a family decides to have 3 kids. Okay? So what are all the possible things that can happen? I created these 3 already for you to make the counting pretty easy. Here the subscript 1 means the first kid, the 2 will mean the second kid, and the 3 the third kid, and so forth. So for example, the first outcome will be something like this. The first kid is a boy, the second one is a boy, and the third one is a boy. So one outcome, not 3, will be this one: B1, B2, and B3. So that will be the first outcome, which would be this. Another outcome will be this, which means the first one is a boy, the second one is a boy, but the third one is a girl. So if you continue this way, this is what you get. You should stop the video and check by yourself that these are all the outcomes. As you can see, the total number is 8 outcomes. So therefore, if a family has 3 kids, there are 8 different outcomes. The last one is 3 girls. This one is 2 girls and a boy, which will be this one, and so forth. By having a tree, it makes counting the outcomes very, very simple. Once you have this, then you can find any probability. For example, let's say that you want to find the probability of this event, the event of having 2 girls and 1 boy. So all you have to do is find all the ones that have 2 G's and 1 B. So in this case, it will be this one, this one, this one, which is 3. So therefore the probability of having two girls and a boy, it will be 3/8. And that's it. Notice, and this is the part that you have to be very careful later, if I erase this part, this is still the same question, because the family is having 3 kids. So having 2 girls automatically should imply that the third one is a boy. So you need to be careful with that, because usually questions are just asked like this. So therefore that implies that you need to understand the rest of the sentence, and sometimes this part will not be given, so be careful with that. Suppose that we have the following event. The event is that the family has no boys. Since you're having 3 kids, that automatically implies that you have 3 girls. Okay? Well, how many in the list have 3 girls? Only 1. So therefore the probability that the family will have no boys is exactly the same thing as having 3 girls. So it will be 1/8. As you can see, if you have the sample space, it is very easy to find probabilities. The hard part, therefore, is to figure out what the sample space is. Let's try another very similar example. Let's say that Nacho takes a test with 3 questions. The first 2 questions are multiple choice, which means he has 3 choices, and the last one is true or false, which means only has 2 choices. In this case, unlike the previous example, the tree is not complete. This represents only the first question. If the first question is a multiple choice, it has 3 choices. One of the choices is correct, and the other 2 are wrong. It doesn't matter where the C1 goes. The 1 just means it's the first question, so you can have C1 in here or C1 in here. It doesn't matter, but you need to have 1 correct and 2 wrong. Before you see the tree, you should stop the video right now and try to figure out the tree by yourselves. The tree should look like this. The first outcome is all the 3 questions are correct. This means the first 2 are correct, but the last one is wrong. This will mean that the first one is correct, the second one is wrong, and the third one correct, and so forth. If we write the outcomes, you will end up with C1, C2, C3, which means all correct, C1, C2, W3, C1, W2, C3, and so forth, until the last one, which is W1, W2, these should be all 2's, W3. The total number of outcomes is 18. You should check this. Now, once you have the outcomes, just like in the last example, you should be able to figure out any probabilities from here. For example, what's the probability that all 3 questions are correct? Well, that means you have C1, C2, and C3. Remember, only one of them has C1, C2, and C3, so this should be 1/18. And that's it. Now, what about the probability that Nacho get all 3 questions incorrect? So here you have to be a little more careful. All incorrect means you have W1, W2, and W3. But you have W1, W2, and W3 multiple times. So you need to make sure you count all of them. For example, this is 1. This is another one, so that's 2, 3, and 4. So therefore, the probability that he will get all questions incorrect is 4 out of 18. And that's it. Alright, finally, what's the probability that Nacho will get the last question incorrect? Well, the last question incorrect, it will be all the ones with W3. So you have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the probability of this one, it will be 9 over 18, which is 1/2. Now this one should be not surprising at all, since the last question was true or false, and if you only look to one question that is true or false, there is 1/2 probability of getting it incorrect, which means there is 1/2 of getting it right. Okay. Now these trees can start being very annoying. The good news is that there is better ways and faster ways to do this later. You will see that in chapter 5. But for now, this is probably the best way to figure out the sample space. It's not the fastest one, but it's the safest way to figure it out. There are some probability rules that they need to be followed the whole semester. And you have to be very careful to check that this is the case all the time. For example, a probability always has to be between 0 and 1. Always. If you get a number that is negative, then the answer is automatically wrong. And if you get a number that is more than 1, then it's also automatically wrong. There are two special cases, this one and this one, which they are not technical probabilities, but you need to be very aware of them. For example, if the probability of an event is equal to 0, that means that's an impossible event, that it will never happen. Like Mexico winning the World Cup, that's never going to happen. Or the Clippers being champions in the NBA, that's not going to happen either. Now you have to be careful that don't confuse impossible with very hard. The probability of winning the lottery is very, 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 very small, but it's not impossible because people do win the lottery. Now, in the other extreme, in the probability of something is equal to 1, that means that E will always happen. So this is a certain event. For example, if you roll a die, the only way guarantee to win, it will be if you bet in number 1, 2, 3, 4, 5, and 6. Why? Because one of those numbers is going to come up. It doesn't mean you're going to make any money, but you're going to win. By win means guess which is the number is going to come up. And if you bet in all the numbers, of course you're going to win because one of them is going to come up for sure. The last part on section 4.1 is called the complement of an event. And this is one of the most important things in probability. And by important, it means that it will make your life very easy in some problems. Sometimes to find this directly, it can be very, very hard. So instead, you find the complement or the opposite, and all you have to do is subtract this from 1, and you will get the answer to this one. You just need to be careful what the complement means. So E with a bar means na E, or the opposite of E. For example, you have E as the event representing Democrats. It is pretty tempting to say that the complement is Republican, but that's not the case because somebody that is independent is also not Democrats. So therefore the complement of E will be not a Democrat. Okay? And you will see that finding the probability of this event, it will be way faster than finding this one directly. Even though this is the one you want, you will find this, and then you will do 1 minus this. For example, let's say that there is some event that it will take you literally hours to find directly, and then you can figure out easily that this one is, let's say, 0.3. That's not what you want, but if you do 1 minus 0.3, it will give you 0.7, which is the answer you want, and that will save you a lot of time and pain and suffering. There is a particular complement that is going to be very useful the whole semester. Let's say you have the event at least 1. Let's just make sure you understand what that means. So let's say you have 0, 1, 2, 3, 4, 5, and so forth. So if your cousin Pedro goes to the market and you ask him to bring you a Pepsi, or at least a Pepsi, if he brings you 1, that's fine, but if he brings you 2, that's also okay, 3 is okay, and so forth. So at least 1 is this part. So therefore the complement of at least 1 is only this one, which will be 0 or none. Hence, the complement of E in this particular example is going to be none. This is going to be very, very useful in the coming chapters, because if you are trying to find at least 1, you will have to do the problem for 1, then for 2, then for 3, 4, 5, and so forth. So if you have, let's say, 100 numbers, you will have to do this 100 times, which will be a very, very time consuming. So instead, you only need to figure out this one, which is the complement, and then you do 1 minus that. Going back to this example, like let's say this is what you really want, which will take a long time. So instead you figure out this one, which is just 0.3, then you do 1 minus 0.3, and it gives you 0.7, and you're done. That is why the complement is such a helpful thing to know. All right, so that's it for 4.1.